For general case, when yield of the rock mass surrounding the reinforcement is expected to occur, the following principles of rock support and reinforcement practice must be applied according to. So, 1, install the support close to the surface soon after excavation. So in general case, if there is that what we call yield of the rock mass surrounding the reinforcement, okay, yield is where I have the rock, and then with time it is going to fill, but I observe that with time, okay, it is not immediate. So it takes time to occur for you to see that this visible deformation within the excavated place. So if there is that yield, okay, surrounding the reinforcement expected to occur, the following principles, what are the principles that I need to put in place? 1, I have to install the support very close to the face. So they are talking about this type of support, the passive one, where I want to install a support, but it is not directly in contact with the rock like the bolting will do. But then if I think there's going to be something called yield, where with time, the material is going to lie on this support system, or there's going to be that failure and finally find itself settling on the rock mass, then I have to bring about the installation being too close to the surface of the walls soon after the excavation. Then there should be good contact between the rock mass and that of the support. And then the deformability of the support should be such that it can conform to the displacement of the excavation surface. Okay, for example, what we are trying to demonstrate here is that, let's say this packing case I have here, okay, this is an excavation I have created. This is an excavation I have created. But as of the time I did the excavation, we have some of the, I have a pin here, let me use that. Okay, so let's say there are some of the support I will have to provide where this is the rock mass surrounding this excavated place or zone I have caused the disturbance. And with this disturbance, I feel that there's that immediate deformation which is going to occur. And so instead of this one falling off, I decide to bring in any support that will hold it in place immediately. This type of support that has an interaction with the rock as soon as possible is what we term as the active. Then we have that of another support which I will bring in place, although there have not been that immediate failure of the rock mass, but I feel there may be soon. And so I bring in a support within, but it is not having direct contact with the surface. Just like that is, for example, the drill. It is not being drilled directly into the rock mass, but I provide some kind of shield within, which maybe I might be working within. So at any point where there is a failure of this rock, where will it, who will receive that kind of shock? It is going to be this lining I have provided. I don't know if the demonstration. The fact that we are saying there is no that direct contact does not mean we have left a gap so huge that it's going to cause failure. And that is why these two authors are saying that you would do that kind of support, okay, but then you should consider doing these three things. Try to bring them as close as possible to the formation, such that at any point, if there is that failure, that subsidence
Okay,
you are expecting wouldn't occur. So if we are talking about meshing more or less, if it is having direct contact, okay. So this type of passive we are talking about is something that can stand on its own as if it is replacing the space you have created. So the mesh cannot stand on its own. We have bolted it. It even comes with bolts, isn't it? So it is an active
yes, please.
support.
Okay.
Good. So we have ideally the reinforcing system should help prevent deterioration in the mechanical properties of. So if there is that failure occurring after you've put your steel shield or whatever within, which is the passive support, it should be something that should help provide or reserve the mechanical properties of the rock mass with time due to weathering, and then repeated removal and replacement of support elements should be avoided. And the support system should be easily adaptable to changing rock mass condition, because it is something more or less like an installed system within the space. It is bound to have some of these issues, and that is what Bray, and then Hook are trying to describe for us to avoid if we are going to adapt a passive kind of support. So 3, the support system should provide minimum obstruction. So you see, it is going to be within the excavated space, and so it should be such that there's not going to be any obstruction as you work. And that is why we as mining engineers, we love to go with the active support so that we don't have any other distractions on our way, because what we are feeding on is the rock itself, which is the ore. And so if I install something within the whole of that space, where then am I going to mine? Am I going to mine that installed stuff? And so you should try as much as possible to have something that do not cause obstruction as support, because it is not going to serve its purpose. It is there to save you and then allow you room to operate. And so if you are bringing in a support that will retard your progress in whatever purpose with which you are installing them, it is not an interesting support system. Then the rock mass surrounding the excavation should be disturbed as little as possible during the excavation process. So for example, even with the rock bolt, let's say because you have installed rock bolts, doesn't mean you should go about doing activities that can tamper with the integrity of the bolting you have done. So method of support. Support are special construction installed in mine opening for prevention of caving of surrounding rock and maintenance of necessary dimension of mine opening. And then a combination of certain types of support with correct method of roof controls is of major practical importance and ensures successful stopping. So if you are bringing in methods in terms of support system, we have special construction installed in mine opening. For example, when we are talking about the portal of the mine, you are bringing in a kind of support that will hold on to the opening for you to have access and do whatever activity you want to undertake. Then a combination of certain support types with the correct method of roof control. For example, we are doing room and pillar, and our ore body is massive, and so we are going longitudinal. So as we operate, we can seal the roof and go along with our operation. And that type of system is also there and possible. Then the support of production phases is of utmost importance for the safety of mining. So that point where we are working at a particular time, okay, we can also bring about certain support systems for our safety. So these are then good condition of mine opening guarantee normal ventilation. So if your support system is good, because ventilation systems are in forms of tubes and fans and whatnot. So if your support system is good, you put in wire mesh, neatly bolted and grouted. It looks like somebody's apartment. When you are in it, you enjoy. Okay, but assuming these things are not done well, you try to pump a certain quantity of air, and this air finds its way through certain cracks, and then they escape. And the man who is working at the face, who needs that air, is not getting that quantity. Meanwhile, you have also calculated very well, and you've distributed your air thinking that, oh, there are 10 people at the face, and so giving them this number of air is enough plus their machinery. But then there are cracks all over, absorbing this amount of air you are sending in there. And so if you have a good support system, it facilitates your ventilation, safety of transportation of loads, and safe movement of people. People work down there freely without any fear. Then mine openings requires constant observation. So that is why you are here studying applied rock mechanics. So if you are privileged to work as a geotechnical engineer, mine openings requires constant observation. So now as you go down there as a surveyor, it wouldn't just be about what you are doing, but you now have certain knowledge regarding rock. And so when you get to a phase and you observe certain discontinuities, or if you see a space being taped out of bounds, you won't just go and take that tape off out of ignorance and say that you have to pick your point. No. So you now understand how unpredictable the rock is. And that's why sometimes when the geotechnical person tells you, do not do this, or there is this failure bound to happen, and they tape the place and you observe like 3 days, 4 days, nothing happens. Oh, omobwa, sana dano a level so so yakoye juma hon mo di tape beto you see. So it is a natural material we are dealing with, and so we try as much as possible to predict it and try to be correct or accurate, precise with our prediction. And so it requires constant observation, and the more you work with a particular place and the properties of the rock, you get a better understanding of it and a better interpretation of what you observe. Then the types and dimensions of support are chosen relative to dimension, value of the rock, pressure, the usage of mine opening, lifespan of the support, and economical consideration. So these are the key things we consider if we want to select a particular support system. The types and dimensions of the material. For example, if it is bolting you want to do, you don't bring in a bolt that is too huge to bring about a discontinuity bigger than the discontinuity you want to avoid. So you have to do your calculations very well and know that, okay, if I bring a dimension of A or a dimension of B, it is capable of holding the two planes together for me to work, rather than bringing in one that has a large diameter that by the time you drill it in, you have caused other discontinuities along it, which are wider than the ones you wanted to close up. And so the types and dimensions are very key here. And then relative in direction and value of the rock, pressure, the usage of mine opening. So if you are installing a particular support system, how do we use that place? So looking at the usage of the place will tell us what type of support system we should put in place. Then we have the span. Every support system you are putting in has a lifespan. So you have to check the lifespan of that support system you are putting in place, and how long you are going to work there. They work hand in hand. And then economic consideration. Yes, so you are using money to buy, and so you have to weigh your options and see which one would be ideal. And again, even their installation, are they going to bring about distractions and obstructions that will prevent productive activities? That has to